Have you ever wished you could travel back in time and change history? Or jump forward hundreds of years to see the future? Science fiction has long teased us with the idea of time travel, but what does real science say? Is time travel possible? The answer may surprise you. Thanks for watching Decoding History and Science, where we unlock the greatest mysteries of the universe. Like and subscribe for more. Let's dive into the theory fantasy. Einstein's theory of relativity, how time can slow down. In 1905, Albert Einstein introduced the theory of special relativity, which changed how we understand time and space. One of its key ideas is that time is not constant, it can speed up or slow down depending on certain conditions. How does time slow down? Einstein's theory states that time slows down when 1. You move at extremely high speeds, close to the speed of light. 2. You are near a massive object, like a black hole. This effect is called time dilation, where time runs slower for one observer compared to another. Example: the faster you go, the slower you age. Imagine two astronauts. 1 stays on Earth. 2. The other travels in a spaceship at 90% the speed of light and returns after 10 years, by Earth's time. Because of time dilation, the astronaut on the spaceship may have only aged 5 years while the one on Earth aged 10 years. This means the space traveler has effectively time traveled into the future. Real-life proof. The GPS satellite experiment. We don't need a spaceship to prove time dilation, it happens every day. 1. GPS satellites orbit Earth at high speeds. 2. Their clocks tick slightly faster than clocks on Earth. 3. Scientists must adjust their time constantly to keep GPS systems accurate. What this means for time travel. 1. Traveling to the future is scientifically possible, just move fast enough or stay near a massive object. Time dilation experiment, GPS proof, real-life evidence of time travel. 3. One of the strongest real-world proofs of time dilation comes from GPS satellites. 3. These satellites orbit Earth at high speeds and experience time differently compared to people on the ground. How does GPS prove time dilation? 5. GPS satellites move at 14,000 km per hour, 8,700 miles per hour. According to Einstein's special relativity, high speeds cause their onboard atomic clocks to run slower than clocks on Earth. 6. They orbit 20,200 kilometers, 12,550 miles, above Earth. According to general relativity, weaker gravity in space makes time run faster compared to Earth's surface. How much does time change? 8. Special relativity, speed effect, clocks on GPS satellites tick 7 microseconds slower per day than on Earth. 9. General relativity, gravity effect, clocks on satellites tick 45 microseconds faster per day than on Earth. 10. Total difference, 38 microseconds per day, which seems tiny but is enough to completely break GPS navigation if not corrected. Why does this matter? 12. GPS needs extreme accuracy to guide planes, ships, and even Google Maps. 13. Scientists constantly adjust GPS satellite clocks to match Earth time. 14. If they didn't, GPS locations would be off by kilometers every day. What this means for time travel. 16. Time travel into the future is real, even if only by tiny fractions of a second. Wormholes, theoretical time tunnels. 18. A wormhole is a hypothetical shortcut through space and time, also known as an Einstein-Rosen bridge. 18. If real, Wormholes could allow for instant travel between distant points in space, or even different points in time. How do wormholes work? 20. Imagine spacetime as a folded piece of paper. 21. A wormhole would be like a tunnel connecting two distant points, allowing for instantaneous travel. 22. If one end of the wormhole moves at near light speed, time dilation could create a time travel effect. The science behind wormholes. 24. Albert Einstein and Nathan Rosen, 1935, proposed wormholes using general relativity. 25. Physicists like Kip Thorne suggest that a wormhole could connect not just two locations, but also two different times. Could we use wormholes for time travel? The time difference between the two ends could, in theory, allow someone to step into the past or future. The big problems. 29. Wormholes are purely theoretical, no evidence they exist yet. 30. They might collapse instantly, making them unusable for travel. 31. Exotic matter, negative energy, is needed to keep them open, which has never been found in large quantities. What this means for time travel. 33. If wormholes exist and can be stabilized, they could allow humans to travel through time. The twin paradox, a mind-blowing time travel experiment. 35. The twin paradox is one of the most famous thought experiments in physics. 35. It proves that time does not pass the same way for everyone and that traveling at high speeds can make you age slower, essentially time traveling into the future. The experiment. 37. Imagine identical twin brothers, one stays on Earth, twin A. The other travels in a spaceship at near light speed, twin B. 38. After several years, twin B returns to Earth. 39. Because of time dilation, from Einstein's special relativity, twin B has aged much less than twin A. While twin A might be 80 years old, twin B could still be 30 or 40. Why does this happen? 41. Time slows down for objects moving closer to the speed of light. 42. Twin B experiences time more slowly than twin A. 43. This is a real effect, not just a theory, it has been proven in physics experiments. Real-life proof of the twin paradox. Astronauts on the International Space Station, ISS, age slightly slower than people on Earth because they move at 28,000 km per hour, 17,500 miles per hour. What this means for time travel. 47. If a spaceship could travel at 99% the speed of light, astronauts could jump decades or centuries into the future while only aging a few years. Black holes and time travel, can we use them to travel through time? 49. Black holes are some of the most mysterious and powerful objects in the universe. 49. According to Einstein's general relativity, their extreme gravity can actually slow down time, making them a possible key to time travel into the future. How do black holes affect time? 51. The closer you get to a black hole's event horizon, the point of no return, the stronger the gravity. 52. This extreme gravity warps space and time, making time move slower for anyone near the black hole compared to someone far away. The real-world time travel effect. 54. Imagine an astronaut orbiting a massive black hole for 10 years. 55. Due to intense time dilation, when they return to Earth, they might find that hundreds or even thousands of years have passed. 56. This means they have traveled into the future just by being near the black hole. Real-life proof, time dilation near gravity in 2019. the Event Horizon Telescope captured the first image of a black hole, confirming the extreme warping of spacetime. Could we use black holes for time travel? Traveling to the past. Uncertain, some theories suggest a spinning black hole could create closed time loops, but this is unproven. What this means for time travel. 62. Black holes might be a one-way ticket to the future. The grandfather paradox, the biggest problem with time travel to the past. 64. One of the biggest challenges in backward time travel is the grandfather paradox, a mind-bending contradiction that suggests traveling to the past might be impossible. What is the grandfather paradox? 66. Imagine you travel back in time and prevent your grandfather from meeting your grandmother. 67. This means one of your parents would never be born. And neither would you. 68. But if you were never born, how did you travel back in time in the first place? 69. This creates a logical contradiction, a paradox that breaks the laws of cause and effect. Real-world implications. 71. If backward time travel were possible, it could allow events to erase their own causes, creating unstable timelines. Possible solutions to the paradox. 73. Scientists have proposed several theories to solve this problem. 74. Multiverse theory, every change in the past creates a new parallel universe, meaning the original timeline remains unchanged. 75. Self-consistency principle, the universe prevents paradoxes by making sure past events cannot be changed. For example, if you try to stop your grandfather, something always prevents you. 76. Quantum time travel, some theories suggest that quantum particles might be able to travel through time without causing paradoxes. What this means for time travel. 78. Traveling to the future is possible, with speed, gravity, or black holes. Quantum mechanics and time travel, could the quantum world hold the key? 80. Quantum mechanics, the science of the smallest particles in the universe, suggests that time might not be as fixed as we think. 80. Some bizarre quantum effects hint that time travel could be possible at the microscopic level. Strange quantum phenomena that defy time. 82. Quantum superposition, a single particle can exist in multiple states at the same time until observed. 82. Could this mean the past, present, and future coexist in some way? 83. Quantum entanglement, when two particles are entangled, a change in one instantly affects the other, no matter how far apart they are, even faster than the speed of light. 83. Could this allow for instant communication across time? 84. Retrocausality, some experiments suggest that future actions can influence past events at the quantum level. 84. This challenges our understanding of cause and effect and could be a clue to how time travel might work. Theories on quantum time travel. 86. Closed time-like curves, CTCs, theoretical loops in time where events can repeat without breaking physics laws. 87. Quantum time teleportation, some researchers believe entangled particles could be used to send information backward in time. 88. Many worlds interpretation, if time travel to the past is possible, it might create a new parallel universe, avoiding paradoxes like the grandfather paradox. What this means for time travel. 90. Quantum mechanics doesn't rule out time travel, it suggests that time may work differently at microscopic levels. Cosmic strings, the universe's natural time machines. 92. Cosmic strings are hypothetical, ultra-thin energy filaments that may have formed right after the Big Bang. 92. Some scientists believe they could be used to create closed time loops, making time travel possible. What are cosmic strings? 94. These are massive, one-dimensional objects that stretch across the universe, thinner than an atom but incredibly dense. 95. Their immense gravity is so powerful that it warps space-time, just like a black hole, but in a long, string-like shape. How could they enable time travel? 97. If two cosmic strings move past each other at nearly the speed of light, they could distort time and space enough to create a closed time-like curve, CTC. 98. In theory, a spaceship traveling around these strings could loop back in time and return before it even left. Why haven't we found them? 100. Cosmic strings are purely theoretical, scientists haven't discovered any direct evidence of them yet. 101. If they exist, they might be extremely rare or spread across the farthest edges of the universe. What this means for time travel if discovered, they could help us understand the deep structure of space-time and unlock new ways to manipulate time. Time machines, could we build one? Scientists have proposed theoretical blueprints for building a real-time machine using physics principles like wormholes, black holes, and light-speed travel. But can we actually build one? Theoretical time machine concepts. Kip Thorne's wormhole time machine. 1. A wormhole could be transformed into a time machine by moving one end at near light speed while keeping the other stationary. 2. This would create a time difference between both ends, allowing for travel between different points in time. Tipler cylinder. 1. Imagine an infinitely long, rotating cylinder made of ultra-dense material. 2. If spun at near light speeds, it could warp space-time, creating a closed time-like curve, CTCA loop that allows backward time travel. 3. The problem. 3. We don't have a material strong enough to withstand such extreme conditions. Black hole-based time machine. 1. Orbiting a massive spinning black hole at just the right distance could create a time loop, sending an object back in time. 2. However, the extreme gravity and radiation make it nearly impossible for a human to survive. Challenges to building a time machine. We need exotic matter. Time machines require negative energy or exotic matter, which hasn't been found in usable amounts. Time paradoxes. Traveling to the past could create logical contradictions, like the grandfather paradox. Extreme energy requirements. A real-time machine would require energy levels beyond anything we can currently produce. What this means for time travel. In theory, time machines could be built if we solve major scientific challenges. In practice, we are far from having the technology to construct one. The possibility of time travel. What does the future hold? Time travel is one of the most exciting possibilities in science. While traveling to the future is scientifically possible, through time dilation and black holes, traveling to the past remains a mystery due to paradoxes and technological limitations. What science says about time travel. Traveling to the future. Possible. 1. Time dilation, via high-speed travel or strong gravity, has been proven with experiments like GPS, satellites and atomic clocks. 2. If we develop near-light-speed spaceships, humans could travel far into the future while aging much slower. Traveling to the past. Still uncertain. 1. Theoretical ideas like wormholes, cosmic strings, and black hole orbits suggest past travel might be possible. 2. However, paradoxes like the grandfather paradox suggest it could be logically impossible. 3. Some physicists believe past travel might only work if it creates new timelines, multiverse theory, instead of changing the past. What could happen next? Advanced space travel. If humans develop spacecraft that can travel near the speed of light, we could send astronauts into the far future. Quantum discoveries. Research into quantum mechanics might reveal new ways to manipulate time at microscopic levels. Breakthroughs in physics. If we discover exotic matter or prove wormholes exist, time travel theories could become reality. Final thoughts on time travel. 1. Future time travel is real, and happening every day, even in small ways. 2. Past time travel is unknown, but physics still leaves room for exciting possibilities. 3. The biggest challenge. 3. We need major technological and scientific breakthroughs before we can fully unlock the secrets of time. While time travel to the future is already possible, through speed and gravity, traveling to the past remains an unsolved mystery. 3. If we discover new physics, such as exotic matter or quantum time loops, we might unlock the key to true time travel. 3. Until then, the best way to visit the future is to wait. 5. What do you think? 5. Will humans ever unlock the secrets of time travel? 5. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon so you never miss an episode. 5. Let us know in the comments, if time travel were possible, would you visit the past or the future? 6. Thanks for watching Decoding History and Science, where we unlock the greatest mysteries of the universe.